Okay, so we would like to resume, the panel discussion. Again, thank you very much, for like incredible informative lecture. It was like just amazing. I think, everybody is already satisfied. I'm pretty, 100% sure. But, why not? Because, we're here. I would like to start maybe, a couple of questions, from me. And then maybe desirably, afterwards, we start to make questions to each other. I mean, you can maybe question to Ryan, also. So, so such kind of flow, I'm thinking. So let me just get started. So I found, again, it was, really, how do I say, eye-opening, to see your development, again, as a perspective of adaptation, as I wanted to, kind of discuss, because if it's the case, for Gilles, like, you start to, understand, to like really be able to change, the industry, you start to understand, the aspect, okay, why not, like rather than making completely new building system, but, like, just to make API, to like really, kind of, infiltrate, into the system. And then, like change, little by little, but, fundamentally, from, kind of the ground. And that was like a, interesting approach, I really found. And then you mentioned also it's very important, to have your system, be graspable, again, only with, spending one day, of like a completely, how do I say, non-professional people, who haven't used, robot. And then that's like, also very, it's easy to say, but like really difficult to achieve. And, such kind of approach, I found like really, again, amazing. And then I feel like it is like literally transforming, like ourselves, to, then what's like really required, if we would like to, again, tap into, this, issue of housing, shortage, problems. And, when it comes to Ryan, I mean, like, it was like really, really incredible to see, how like you are actually tapping into these, like, the discipline of, the almost like the world itself. How like material, is behaving in front of us. And if we do, if we simulate what, how we can understand, all those, mechanisms, of the world. And, we really witnessed today, like in how your, like, step-by-step development, finally, comes to like, those autonomous, dry stone assembly and this Gravis robotics in the end, And, so those, system, I feel like really changing our mindset, yeah, like we have never thought about, okay, dry stone assembly, when we would like to, make, those, retaining wall. But it is, as a matter of fact, 78%, reduction of CO2. Then, like, why not really, maybe, that's the choice, that we should make. And then that's like a kind of making question to us, maybe that's like really the way to go. And I would like to know, how do you think, like, and how we are like really different, from before, after, like, say, your project, is being somewhat, starting to be implemented. And what's really the next question, or I mean, next research question, I can say, which we didn't even know, or we even didn't imagine before. So that's, somewhat maybe, starting point, and I would like to make a question to both of you.
Yeah, I think now it works. I mean, I think it's actually probably quite similar, Ryan, your experience, but like what I thought was very interesting with me is the moment that you leave the kind of academic lab, you are also just generating all the what's next questions. They are thrown at you all the time. Because in an academic lab, ultimately, what happens is that you set up a series of constraints and inevitably you create kind of your own world where most of the things you try are kind of working. And the questions that you answer are the kind of questions that you have come up with in a way as constraints. The moment that you go into the world, digging in the real world, like you are doing, or in my case, trying to, work with construction workers and companies, suddenly you realize all of the questions that you haven't asked, right, in your perfect world. And I think we are continuously in a situation that we discover, it's kind of a machine for knowledge generation and discovery. The moment that you step outside with a simple hypothesis and you're like, we're going to do this now. And then suddenly you understand all the 100 reasons why this is super difficult to do it. And those are like, we are every day, it's like, what's next? Yes, this we need to solve, this we need to solve. Then, of course, if you zoom out a little bit further, I think, as a company, we have a whole product roadmap where we want to go. So there are some obvious ones that the whole way we have built the software infrastructure for our will go into an opportunity to make it a fully generative design-based framework. Initially, that was our first idea. Like, we developed the software because we wanted to generate building designs. Then we learned this is a bad idea to do that first. You actually probably want to do it last, right? So, but that's definitely something that will come very well set up now to begin to work on it. And then a second bit is ultimately, and that is really interesting to see the overlap with Ryan, is to begin to make our technology even more generic or generalist, is to really add more intelligence to being able to tackle differences in materials, et cetera, et cetera. And like there is a really interesting scope there for obviously some of the systems you're already working with, right? Like adding better vision capabilities, et cetera, right? So to essentially add even more autonomy to that process so that we have even less work as a company.
Yeah, I mean, I think kind of if I look back on what changed in the last decade or something in architecture, I think part of it was a focus on kind of coming to practicality, maybe if I look at it a bit cynically. I think early on in the kind of digital architecture wave that I talked about, a lot of the challenges were free from capital, right? There was a lot of wealth in the market, and people just spent a lot of money on architecture. And then you kind of moved gradually away from that after the 2008 crash, and there were a lot of people working in the lab scale in digital fabrication and in computational design. And the idea was always, and the lectures were always, this can make 1 million buildings where everyone is different. But you only ever saw one prototype, or at best one building, never 1 million, right? And I think the thing that was missing there was the consideration of cost. It was the consideration of practicality, the consideration of labor, and all of those other very kind of non-sexy parts about building architecture. And I think that architects, myself included, are just bad at that, right? It's not what you want to think about. You want to make this beautiful thing. You want to make a system to build beautiful things in the world. And it feels like, once you make the first one, you prove it's possible, let's move on to the next thing. And I think that, as I would say, I built a career making prototype systems that I did one thing with, and then I forgot to put them on the shelf. And I think, the impact there is the impact of thought, right? It's the academic impact of, can we influence the next generation to build better, to think about it? And I think in a way, I sometimes question which has a bigger impact, right? Building 100,000 houses or driving 1 million autonomous excavators, or teaching 100 or 1,000 architects a new way of thinking, who will then go on to teach 100 or 1,000 architects a new way of thinking. And those ones will start startups, right? So I think there's value in both worlds. Mm-hmm. And I think the question is really how do we, from now this kind of startup angle where we're hypersensitive to things like cost and finances and budget and all of those things, how do we bring that expertise back into the kind of younger generation who's coming up practicing architect and kind of understanding how we fuse those things also in academia from an early stage.
Maybe that very actually answer leads me to ask for the very next question. But I think now audiences ranging from professional actually engineers or architects and architecture students and engineering students also. And I think they should be wondering say, as an architect, or maybe if it's engineer as an engineer how we could potentially be able to develop a collaborative relationship to achieve something which projects like you achieved or implemented, or the thing that you just described to be in this next step, maybe education, or maybe project generation, maybe one specific unique one, or these large quantities application, where again, as an architect or as an engineer, we can tap into this issue. Where is the how do I say key critical point to promote collaboration between those different fields, you think?
It's a great question. I don't have the answer to the way it's done best. I can say that one of the reasons I went to Switzerland is because I think they do it really well there. So for those who maybe can't judge by the accent, I'm from the US. I went to Switzerland for my PhD. And I think one of the things that they've done for a long time there is put funding at the national level into collaborative projects, right? So in my PhD, we built a wall with 1,000 one-ton boulders that's 65 meters long. And if I think about what most PhD students build in the US, it's like some hot glue in a pile that fits on the corner of your desk, right? It's not, you don't get to that level of support. And that was only possible because there was a funding instrument which said, we're going to pay computer scientists salaries, we're going to pay robotics salaries, we're going to pay engineers salaries, and we're going to pay architects to all work together to solve this very, very complex academic problem. And so I think that is an approach which Switzerland as a country takes. And I think that overall is something that certainly pushes things forward. So I think across the globe, if there is that kind of national movement toward pushing collaboration, that's gonna happen. I think in the US you have a lot of academic labs where one professor goes to get funding, and it essentially the funding instruments makes them work as kind of very independent individual practices. So yeah.
It's also, I think it's also interesting, like we've really experienced this with our building a team that was initially just architects, and then gradually adding computer scientists, structural engineers, roboticists, business people, operators. And then you really see that value, right? Because obviously the architects have a very specific way of looking at a problem and of working. And then the real power emerges when you combine them at the same table with this computer scientists, these engineers. And it's true that we somehow are, maybe because of the way that academia is structured, often like too foreign to those other disciplines. It's very, very siloed. And at the same time, the challenge is also that all of them have their unique, they're all unique assets and their unique properties. So you don't actually want to do a university course where you're a little bit of engineering, a little bit of architecture. It's important that they are their own disciplines, but creating more possibilities for actual interaction between those disciplines is important. Because like we're seeing in Europe now a lot of courses that are becoming this kind of architectural engineering, which I think is also like not a solution. Like it's interesting if you maintain the core of the discipline and try and create environments where people are forced to problem solve together. And one of those environments are startups, right?
Well, it's the interesting point. I think is the as a matter of fact, and I feel like so those, how do I say, circumstances, oriented, discussion, of course, there exists, for how to promote, collaboration. But, as you, said, you started off, only, as an architect's team, and, but gradually, again, starts to expand your collaboration relationship. And what do you think is the, I don't know, like almost like maybe attitude or strategy, how to, like, what actually excites, this communication between, those different territories, of people? Like, we normally have, different, vocabularies, like, even for me, when I started, to work on, some, GPS-oriented, projects, and then I started to communicate, with, computer science people, like first 15 minutes, communication is almost impossible, because, the language we had, is completely different. But, in that kind of, moment, how you yourself, maybe, as an architect, somewhat being involved, with those experimental things, yeah, how you could, develop, those, collaborative relationship with, those, I don't know, so to say, engineers, maybe.
I wish I knew the answer. Our team is, I would say, we're probably 95% engineer. And my PhD, I was 3 days a week in a robotics lab and 2 days a week with architects. So I kind of, over time, I shifted to where I, wear the engineering hat a bit, maybe too heavily. But at the same time, I think there is a communication difference. There's a way. I mean, I love the way you put it. Architects make problems and engineers solve them. I think it's not always that, right? I think that sometimes architects can solve problems and engineers can certainly make problems. But it's basically that. I think the biggest thing is finding the value in one another, right? Like that. It's easier said than done. But we're all familiar in the construction industry of construction people or engineers bad talking architects, right? They're the most frustrating people. They change the plans. The drawing was wrong. They're not careful. But then in other things, they're very, very careful. But then, I think typically when the building is done, there's an immense pride in that final result, in that foresight to kind of think through all of these little details and to bring them into a whole that has a vision, right? And I think that's in a way the burden of the architect is to say, we're pushing this thing forward, and there's going to be a lot of critiques, but it's going to come together in something that has meaning. And I think as soon as you have a relationship where people have seen that cycle and they've been through it, and they start to see, okay, yeah, I'm really focused on this detail here, but I'm trusting that detail and this detail and that detail are going to come together for something that's magnificent that I can share and that I can, walk through with my family. I think that's the kind of spirit of that collaboration. But I think it can be difficult until you do it the first time, right? I think it's for everyone. It's difficult the first time you get those people together because they don't necessarily have that trust that what's going to come out is better because of the collaboration and not worse.
Like one way to do it is like mission alignment. So I like this ideas of missions, right? So mission is obviously, you could think about the moonshot trying to shoot a rocket to the moon. It's a clear mission. No single discipline can do that mission, right? But there's an overarching goal that is very, very tangible to everyone involved, and everyone knows just by themselves it will not work. So I really like this idea of bringing teams together with different expertise around a shared mission. So the key bit of communication is making that mission actually very, very clear. Like, what is it that we're trying to build together, right? And like one really, like I always love this example, like there is this idea that even to make one of the simplest objects on Earth, a pencil, right? No single human can make a pencil because you need graphite. You need to put a graphite inside a bit of timber. And so even to make a pencil, you need a whole group of people to do it. So that I like this idea of the mission. And then The second thing is one of my observations that I now always tell to like architecture students is the fact one of the key problems of architects is that they only talk to other architects. They're only friends with other architects. Their whole world is just talking about architecture with architects. And it's really, really interesting the moment that you try to talk about architecture with your parents, with an investor, with a client, because you have to reframe your ideas so that they're understandable and sensible for people who maybe, you know, don't share your vocabulary, don't share your interest, right? And it forces you to communicate, again, around this idea of mission, around this idea of like, our mission is to create this specific thing that we think has value, that is not just value for the architect, but it's value for everyone involved in that mission. So it's a very good practice. Talk about architecture with non-architects.
Yeah. It sounds promising, what you're describing. And maybe, you know, I could move on to maybe, you know, next, you know, topic, you know, somewhat, you know, but, you know, as time is actually very limited, you know, in this session in which I can see like we have roughly 7 minutes left. And then because, you know, what you have developed, you know, like technically speaking also is very interesting, I'm sure, you know, for all those, you know, people. So maybe we can start to, you know, collect, you know, this Q&A, you know, from audiences also, if you have one.
はい、ありがとうございます。日本語でいいですか。はい。どれぐらいのスパンで、そのご自身たちのプロジェクトが理想の形に到達するっていうふうにこう考えてらっしゃるかっていうのをちょっとお聞きしたいです。今はその過渡期、プロセスのだいぶこう途中なのか、あるいはかなりこう自分たちが思い描いているプロジェクトのゴールに近いのかっていうことをちょっとお聞きしたい。
So yeah, how much of, you know, time frame, you know, you're kind of imagining for you to complete, you know, your ideal achievement? And, you know, are you in a, you know, state of, you know, transition for now? Probably yes, you know, but you know, the degree, you know, of your challenge, you know, is where you are basically.
I think we are maybe like somewhere 5 to 10% in the in the process. Yeah, like the very beginning. We've just scratched the surface, and yeah, and so I mean, I see. I mean, it's an interesting question, right? Like, when is this kind of done? Like, we are obviously both of us are operating on under quite a lot of pressure from like funding environments to go relatively fast. So my horizon for now is 2030, so 5 years to get halfway, and then another 5 years to go to 100% probably.
Yeah, I mean, I think what's interesting about a startup is that it changes your time horizon, right? I think when I first take your question, I think about it on my own journey, right? Like, where am I in my journey? And if I think about life expectancy, I don't know, halfway. But yet, when I think about, you know, Gravis's journey, yeah, it's probably fair. You know, we're probably 5-10%. But yet, that doesn't, you know, it should exceed, you know, 50% much sooner than I do, right? I think because you're working with a team, because you're working with support from venture capital, you start to get an acceleration, which then means that in your lifespan, you can see more than what you would see as an individual doing, you know, experiment after experiment after experiment. It's by working collaboratively, we can start to grow something faster to where hopefully before I'm at 100%, Gravis is already well past 100%.
Maybe, you know, the thing again, you know, I wanted to ask, you know, is, so I asked, you know, the next research question, you know, as a, you know, rather kind of far target. but I know again, because you're in a 5 to 10% point, you should have very immediate questions that you need to tackle in coming days maybe. And if you can introduce a little bit about those next challenge of your maybe practice, or I don't know, yourself also, it would be very interesting to listen to, I think.
We just made our strategy for next year, so it's good timing. We had to do our kind of 1 year budget and 1 year planning ahead, what the biggest challenges are for us as a company. And it's really interesting. Our challenge is not actually technological. The challenge for us is, if we give these robots to building companies, how can we support them in such a way that they use them like 60-70% of the time? Because our biggest fear is you give that robot and it does nothing, right? Because then we don't make money and we don't learn. So the most important thing for us is to build almost the human side of this business, is to what do we need in terms of people and infrastructure to really drive the usage of these robots. Because we want to, at the end of next year, we want to be able to say, this company used this robot to the maximum, right? And that is a very, very complex question. It's not a deterministic answer. It's about building human relationships, really understanding the problems of these companies. And then what you learn, obviously bring it back into the technology so that you can create a kind of flywheel and start accelerating. But so our challenge is a very human challenge. It's not a kind of a purely technological or robotic challenge.
Yeah, actually, I would say quite similar on our side, right? As we try to grow technology, and as a startup, you're really trying to grow volumes quite quickly. You have to be innovating on how you do that, right? And the way that you deliver 100,000 of something is very different than the way you deliver one, right? So if you're coming from a bespoke architecture world where everything is kind of handcrafted and you migrate to 10, all of a sudden there's a different way of doing that, and then a different way of doing that at 100. And so I think as we look at getting systems out, there's that people bandwidth problem of, do we have enough people to go and talk to these customers, to build the service and support relationships, to be able to manage that growth. And at the same time, it is about proving that technological readiness in the real environment, right? It's one thing to have an excavator dig a hole. It's another thing to have an excavator dig a hole in a real context, in soil that you've never seen before, with rocks that you've never encountered, and have it maybe on a machine type that you've never seen before, and have that deliver value which exceeds by far the current status quo, right? So it's many, many variables. And I think that's where bringing any new kind of technology into construction, there are growing pains, right? There's a lot of challenges that come from working within the very complex operational constraints. And I think for us moving forward, there's a strong focus on working with partners to essentially learn that. So we think we both benefit from having good construction partners who see enough into the future to say, we know we need this technology to be relevant, to be able to keep doing our job, to be able to bring more of the things that the world needs into the environment. And so, they're willing to support, they're willing to teach, they're willing to kind of learn together. And I think that's very much what we're focused on right now, is essentially proving out that technology across a variety of conditions, but not too much variety that we can't actually, that we get overburdened by the amount of complexity and human need for that workload.
Right. Okay. So technically, the time is up, but if maybe, we have one last question. Yeah.
Hello. I would like to ask both of you. My question, I think it's kind of hard to respond to, let's say, with a clear answer, but I would like to know your opinion. I saw in both of your presentations using GitHub and BIM, Revit Kinect or the devices that were kind of really ahead of the time. But for me, digital architecture and post-digital architecture and computer architecture is really connected with Rhino and Grasshopper and this kind of stuff. So basically, my question is that for me, Rhino and Grasshopper is kind of the thing of the present, or maybe a not so distant past. What do you think? What about the future? And especially now with AI tools, and everybody uses especially more about image creating AI tools and this kind of stuff. But I see now progress in more about using AI for creating the spaces and basically trying to replace architects as the inventors of the space or this kind of stuff. So I will just simplify it. Do you think that we still continue using Rhino and Grasshopper for now on, or the current is going into any other direction and we should focus on something else to catch up early? Thank you.
It's a great question. I mean, as a fond Rhino user, I would say, I do sometimes now use AI to drive Grasshopper, right? I think that's a quite useful tool if you have something that you want to get done and you need a way to put it together. I think that where a lot of the AI tools have gotten really good is in kind of creating visuals. And if you can describe it, and I think that's where there is a nuanced difference, right? That's the value of the architect, is in describing. It's in that ability to navigate kind of a difference of dimensional space, to take a 3D thing and put it into 2D, and to then take that 2D thing and put it back into 3D, or even to describe a drawing in words. And that kind of translation between scales and spaces, I think, is going to continue to be relevant, right? It's taking a concept and describing it in words to an AI agent. And that just like you have a lot of buildings that are built without architects, I think you will have a lot of buildings that are designed by essentially ChatGPT. It won't make them great buildings. They will just continue to be like the things that we know. But I think you will also start to see new forms. And for those of you who haven't seen it, I highly recommend playing around with Meta's new SAM 3D thing, where you can basically put in an image, a photograph of anything, and it will make a full 3D model from one image that is textured, that is complete, that is, it blew my mind. And so I think now with the ability to take a sentence and turn it into an image, and then take that image and turn it into something spatial, I think it is going to change the way that we work immensely. But what none of those tools have been able to do yet, and I think the yet is important, is understand the kind of physical space, and to understand things like the nails, and to understand things like the way that a tool needs to approach a problem. And for that to happen, you need to live experience in the physical world. And I think, if we look at the way that the environment is right now, there's not a lot of opportunities for AI to understand those kinds of explorations, right? So I think we have a role for Rhino and Grasshopper in understanding those individual elements and those material assemblies for at least the next 5 years, because we don't yet have millions of humanoids out kind of manipulating things and understanding. And I think without that physical intelligence of bringing robots out into the world, we're not going to be able to teach AI to be able to create those kinds of physically possible assemblies, because it doesn't have enough experience. There is one place where I will say there are already millions of robots out in the world today, and that is if you look at hydraulic equipment as a robot, right? So for us, there's not millions of humanoids, but there are a lot of big, heavy pieces of iron driving around construction sites, and our hope is that by putting technology onto them, we can already start gathering that data to create a kind of more powerful way of modeling and kind of in understanding the environment over time.
Yep. And maybe my take quickly on that, I do think that we probably live at the most exciting moment in time for software in design and construction. like this is a moment where things will radically change, right? Like the old ideas of like even things like Grasshopper ultimately now is quite a little bit of an old-fashioned idea. It comes from, you know, really this idea of like explicit programming. And today, like, I mean, I come from that world, right? And I remember using the very first version of Grasshopper, and it was amazing. But like, if you look at what you can do now, there's, you know, you could just essentially prompt any kind of like plugin or software that you want to use, right? There's no reason to operate within something like that. So I think the kind of discourse around Grasshopper that is based on kind of very explicit ways of approaching geometry is probably on the way out or will be redefined. So I think it's now an incredible time to fundamentally question what a design software looks like. I'm following personally a whole number of companies that are trying to reinvent CAD software from scratch. And some of them are amazing, some of them have very bad ideas, but it's a great moment to really question like how we work. So I think, like I think we'll see a lot of people trying to kind of do another version of Rhino, another version of Revit, and all of these things are shaking up right now. And I similarly, when I saw Sam, the Meta's new AI algorithm, I was like, whoa, this is starting to get scary. Obviously, the reality is the mesh it produces is so messy you can't do anything with it. But it's a great. I mean, like this is a first step, right? So it's going to be really interesting the next like few years to watch that.
Okay. So maybe we have to wrap up the session. So thank you for the great question. I think we've got like interesting actually points of discussions also popping out from this question, which is. So yeah, we have now AI. We have still have Rhino and Grasshopper, and we have also aware now that yet physical aspect is not fully connected to those things. And then if we step back and then look at where we are, how we can see all those fabric of problems and resources that we have. Then we can all ask ourselves, okay, so what's the next question again from present from these sessions. So with that I would like to close today's session. Again, thank you very much for the great lectures, and then thank you very much for everybody to realize this session. Thank you.